Dear students, we have discussed about short-sightedness. Now we will discuss about far-sightedness. A person suffering from hypermetropia can see far objects clear, but they are not able to see the near objects clearly. In hypermetropia, the image of the nearby object is formed behind the retina. This is because the light rays from the nearby object, that is within 25 cm, are focused at the point behind the retina. In this defect, the distance of near point increases and becomes greater than 25 cm. A person with hypermetropia finds difficult in reading book or a newspaper. That means suppose I remove my particular specs, I will find difficult to see small objects clearly. If I use little bit small objects. Now once I use my specs, it should be clear for me. For reading anything I read, it becomes very easy for me. Now the defects may arise. What could be the reason for that? The defects may arise because of increase in focal length of the eye lens. If the focal length increases, this could be the reason. This is due to inability of the ciliary muscles to contract. Therefore, the focal length increases. Number 2, shortening of eyeball. In the other one, it was elongation. Here it is shortening of the eyeball. When the eyeball becomes shorter than the normal, the distance between the retina and the eye lens decreases. As a result, image is formed behind the retina. This defect can be removed or could be corrected by using proper convex lens with suitable power. This convex lens provides additional converging capacity or power required for forming the image of the nearby object on retina. This situation is normally corrected with the help of an ophthalmologist, or we visit an eye specialist. They will check us and give us a correct requirement of the lens, power of the lens, what power of the lens we require. They will just put out here and they will find out and tell us what could be the power of the lens required. Next we have presbyopia. Presbyopia is an age-oriented defect. In old age, the power of accommodation of eye decreases gradually and the near point recedes away. The ciliary muscles become weak and are not able to contract enough to decrease the focal length of the eye lens adequately what is required. In this case, the objects at the normal near point, are not focused on the retina and the person finds it difficult to see the nearby objects comfortably and distinctly. This defect is called presbyopia. And in case of presbyopia, you are not able to see near objects clearly as age factor comes and the ciliary muscles are not able to contract and expand, and ultimately what happens, the focal length ultimately decreases. These defects arise for what reason? Number 1, the gradual weakening of ciliary muscles. Number 2, diminishing flexibility of the eye lens. As the age comes, it has been constantly used for your life, and therefore the eye lens loses its capacity of diminishing the flexibility, what we call. This defect is corrected by using a proper convex lens with suitable focal power what we call it, or the power of the lens. A person may suffer from both myopia and hypermetropia. The combination of this defect is common among elderly people. The defect can be corrected by using bifocal lens, as I am using a bifocal lens. It is having, if you see properly, there are two lenses together. One is for far objects and one is for nearer objects. If you see properly, there are two gaps. One will see, one at the bottom you can see, this area down you can see, it is made a curve line, and on top it is different. So we are using this lens to see near objects as well as far objects. Suffering from both combination, use bifocal length. A bifocal lens consists of both concave and convex lenses. The upper portion consists of concave lens and the lower portion consists of convex lens. The lower portion and the upper portion makes the persons see clearly near and far objects distinctly. Sometimes the crystalline lens of people at old age becomes milky and cloudy. This gradually reduces the amount of light reaching the retina. This defect is called cataract. This can cause partial or complete loss of vision. The vision can be restored through a cataract surgery. In today's world, pico-surgery or pico-surgery, what we call is very best. LASIK surgery is available. This way they can be removed. They remove the particular whiteness patch and they put the new lens. Artificial lens are put, silicone lens are put, and the person becomes exactly alright. Now, the near point of a hypermetropic eye, suppose we take it 50 centimeter. What should be the power of the lens required to correct this defect? Assume the near point of an eye is 25 centimeter. So we take u is equals to minus 25, v is equals to minus 50, f we have to find out what is the focus. 1 by f is equals to 1 by v minus 1 by u. 1 by f is equals to 1 by minus 50 minus minus minus, that is, I'll again repeat, 1 by 5 is equals to 1 by minus 50 minus 1 by minus 25 is equals to minus 1 by 50 plus 1 by 25, or minus 1 plus 2 divided by 50, which is equals to 1 by 50. So focus is equals to 50 centimeter. If I convert it into meter, 1 by 50 into 100, I get it 2D. So the power should be 2D. In next video, we'll try to find out how, for example, dispersion takes place of light, how the rainbow formation is there, how the prism works, what is atmospheric refraction, how the sunrise becomes advanced scattering of light, and so many other things we'll be discussing.